Hello guys, and welcome to another video. It's been a moment since I last posted a Project Euler video. Today we're going to be solving problem 32, which is the Pandigital product. We should say that an n-digit number is Pandigital if it makes use of all the digits 1 to n exactly once. For example, the 5-digit number 15,234 is 1 through 5 Pandigital. The product 7,254 is unusual, as the identity 39 times 186 equals to 7,254, containing multiplicand, multiplier, and product is 1 through 9 Pandigital. Find the sum of all products which multiplicand, multiplier, product identity can be written as a 1 through 9 Pandigital. Hint: some products can be obtained in more than one way, so be sure to only include it once in your solution or sum. Okay. So this is not a difficult problem. We just have to figure out exactly what our ranges are and how to find if a number is Pandigital or not. And once we have those, we make sure that we put them in a set because we don't want any duplicates. And pretty much that's it. Depending on how you write this, you should also figure out what your range of numbers should be. What's the maximum a range that you need to be able to combine and get up Pandigital numbers. So what we're looking for is a 9-digit number. So what we can do is we could take some number, multiply it, and see how many numbers we get. So if we take 3,000 multiply, we're gonna get 6,000. So that is already if we take 3,000 times 3,000, we get a 7-digit number. So we know that we have 3 more spaces that we need. So we can start the next number at 100, right? For the inner loop, and for the outer loop we can keep it at 1. So that should give us a range to work with. But let's get started with this problem. So what I did already was I just created a class in Java, and I called it Euler 32. All right, so the first thing that we need to do is we need to go ahead and generate the digits 1 through 9 that we're going to be using to solve this problem. So I'm just going to create a private static int array method. So we should be able to use this to generate 1 through 9. So what I want to keep track of would be the final variable. So call this one size. It's going to be equal to 9 because we just need to go through 1 through 9. And then we need another variable for the array, and since it's going to be static, we can make it final, and let's call this r. This is going to be equals to new int array, and this is going to be the size. Then what we can do is that we can do the low high thing, where we can generate an array in the length divided by 2, all right, plus 1. So we're going to make this low, and then we're going to create another variable. We're going to make this high. So just think of binary search, for instance, but not exactly. All right. So, all right. So what we can do is either use a for loop or a while loop. It's up to you. It's going to say while low is less than the high. You're going to do low plus plus and high minus minus. All right. So what we want to do next is we want to say that the array and the low subscript is going to equal low plus 1, and for high it's pretty much the same thing. We're going to do high is going to equal high plus 1. So if this was an even array, this will be fine, but this is an odd array, so this won't take care of the middle number, so we have to take care of that ourselves. So we have to create r, and then we're going to use size, right? We're going to divide that by 2 to give us the middle, and then to actually get the number we need to actually say that the size plus 1, then divide that by 2, and that's going to give us 5. And then we can just go ahead here and return r. These are just minor tweaks so that the program should run a little faster. Nothing to it. Next, what we want to do is check to see if a number is Pandigital. So we create another method for that. This is going to be a Boolean. I'm going to say is Pandigital. All right, and we need to take in a string. It's easier to use a string here and just call it digits again. So what we need to do is just keep track of the size. It makes it easier to type and accessible. So let me just call this length, since we're dealing with a string. It's gonna be digits dot length, and then what we need is that array that we created earlier. So final var r is gonna equal to digits. Then what we need to do is check for the length of the string. So we're gonna say if the length of the string is less than 9 or it's greater than 9, then it's not a criteria that we're looking for. So you can just go ahead and return false. All right. So now what we need to do is we need to go ahead and use a set so that we're able to see if the values in our digits string does actually meet the criteria for the strings that we actually need, which we should contain the values 1 through 9. So what we can do is we can use a set for that. The reason I'm using a set for that is because access time is all one time, and since it uses hashing, and also since it doesn't accept duplicates, it might actually take the time down to check for numbers that are not Pandigital. All right. So what I'm gonna do is create a variable set. It's gonna equals to new hash set, and let's make this integers. So we're gonna do the exact same thing with the low and high again. So we're gonna say var low is gonna equal to 0, and high is gonna equals to length minus 1. All right. So now no, let's just use the while loop here. So I'm gonna say while low is less than high. What we want to do is we want to take the digits here, or the characters here, and convert them into integers. Okay, so we do set dot add, right, and we can use the character class and then use the get numeric value. And we're gonna do digits dot charat, and then we're gonna pass in low. And we can do the exact thing here for high. So I'm just gonna copy this and paste this, and then change this to high. All right. Now we need to increment and decrement. So we're gonna say low plus plus and high minus minus. And since this is odd, we still have to go ahead and take care of the middle part. So we just do that, add, and you know what? Let me just do this here. So I'll just paste this again, and here to get the middle number, it would just be the actual length, right, divided by 2. All right, and then that should give us our middle number. So what we need to do next is go through a for loop. We're going to say for var a in r. So we're going to check that, make sure that every number that we have in r is going to be as part of our set. If it's not part of our set, then it's not Pandigital. All right. So we're going to say that if not, then set dot, and then use the contains method. It doesn't contain a, then we can just go ahead and return false here. If that passes, then we know that we are at the end, so we can return true. And I don't know why it does this sometimes. Come on, Jesus. All right, just drag this here. There we go. Okay, So this should check for the number is Pandigital. All right. The next thing we want to do is actually figure out how we need to build the string, and it tells us here that we need a multiplicand, a multiplier, and the product, so we can do that. So let's create another method. Do a private static, and let's make this one a string because that's what we need to return. And let's call this one build, just for short. And we need let's take into integers. Let's do x and y. All right. So we need to create a string. CR is going to equal to, so we can do integer dot toString. Let's pass in x here for the multiplicand, and plus integer dot toString y, and for the product it's going to be integer toString y times x, or x times y, no difference. All right, so now let's create a variable for the length. So this is going to equal to str length. All right, and then we're going to check for the distance as well. So we're going to say if the length is less than 9, or length is greater than 9, then we can just go ahead and return an empty string. So just return empty. If it passes, we could just return str here. Okay, so now that we have that, we're ready to go ahead and actually sum up our Pandigital numbers. So we're going to create a private static int, and just going to do sum Pandigitals. All right, let's take in a start here and here, because we might need to tweak our values. So remember, it says that we can't have duplicates, so what we need to do is keep a set for the Pandigital numbers. All right, this is going to be an integer. Okay, so we can create a for loop, and it says while the start is less than or equal to the end, we're going to do a start plus plus, and then we need to find the combination. So we need two for loops. We're going to say while the let's do their inner is going to equal to start, right, plus. So if we multiply, if we have a max number and we multiplying it by ones, right, we should be able to get those numbers back. So if we have like 1 times 2, then it's only going to return a number within a very small range, so we don't really care about those. So I think the next number that we really need is a number that's higher up, so we can put that in the hundreds place. All right, so let's just go ahead here and add 100. All right, and if the inner is less than, let's see, so it's as less than or equal to the end, do inner plus plus. All right, so now what we need to do is pretty much just build our Pandigital. So what we're going to do is we're going to say if is Pandigital, and then we're going to pass in build. We're going to pass in the start and inner loop, right? If that's it, then what we want to do is we want to do a set dot add start times inner. All right, and this should take care of it. So now what we want to do is we want to go ahead and sum up the set. So we're going to do sum set dot, and then we can use the streams API and the reduce method, passing 0 for the identity, so it starts from 0, and then we want to use the integer, not the compare, but the sum method. All right, and that should sum up everything. So the next goal here is to figure out where we need to go ahead and end the actual loop. Okay, so we're gonna figure that out soon. Okay, so let's do SRT. Some Pandigital. All right, so if we start at 1, right, that's good enough. But the problem is, where do we end? Because if we start at 1, we know the next number we're going to get is 100. Then if we have 2 numbers, we know that we need another 7 numbers. Okay, so that's how we're going to figure out our range. And by looking at this problem, it should be a number between 2,000 and 9,000. All right, but you can figure out this in the 2,000 range. So the maximum number based on my calculations should be 2,000 for you to be able to get the correct answer for this problem. All right, so we're gonna pass in 2,000, and then we just need to go ahead and run this. And let me pull this out for a second. And this is the actual answer for this problem. All right, if you don't add all of the minor tweaks to this problem, it will get really difficult to get the right answer. So make sure that you have to make sure you check for the length of the strings if you want to go ahead and write your own version. I'm assuming that you're here watching this video because you're probably lost and you just need some help or some guidance. You don't have to write the code the exact same way I wrote it, but I've added very small tweaks to my program to make sure that it runs optimally. And what we can do is just take a look at the runtime for this. I haven't actually had time to check it, so let's just start equals to system.currently, and then we can do the same thing for the end. All right, and let's just print it out. So I'll do SRT here, and then I'm gonna cast the end minus start and divide that by 1,000 to get that in seconds. And I'm just gonna go ahead and just add seconds here. All right, and let's see how fast this runs. So it runs in 0.29, so about three of a second. Okay, so this is pretty fast, but you don't have to write your code exactly the same way I've done it. You can just figure out the ideas of how to get this to work and then do it as well for yourself. All right, guys, this will be it for this tutorial. I hope you guys enjoy it. I'll see you guys in the next one. Hopefully I can make a video for Project Euler every week, but I'm gonna limit it to just one video a week. See you guys. Please don't forget to subscribe. Bye bye.